Hi, I'm CJ, and this is my RC channel. In this video, I'm going to be doing a major modification to the Ender 3 Pro. It is a boden tube style printer. In other words, the extruder is mounted away from the hot end, and there is a flexible tube that connects the two, through which the filament travels to get to the hot end and then melted and then laid down on the project board. What this kit does, this is a direct drive kit. It's about $35, and it moves the extruder mechanism with the stepper motor onto the bracket where the hot end is mounted. So it's directly above the hot end, and it eliminates the length of the boden tube. There's a short piece of boden tube that goes from the extruder straight down into the hot end, but it's only about an inch and a half long. That's going to allow for potential for less clogging, because there's going to be less retraction distance. If you understand how 3D printing works, the stepper motor is forcing filament into the extruder, through the extruder, into the hot end. And there's times when, how to describe it? Okay, you're applying pressure to squeeze this stuff out, kind of like a tube of toothpaste. And at some point, when the mechanism wants to stop and create a new line, it has to back off that pressure. And to do that, it has to slightly retract the filament from the extruder, pulling it back into the boden tube. Now, if it's running very hot, if you're having any issues with cooling, if you've been doing a very long print, this is an opportunity for clogging, where that hot end of filament goes back into the boden tube and can cool in the boden tube, blocking it. So the less back spinning there is, the less the filament has to be withdrawn distance-wise, and it's normally a fraction of a millimeter or a couple of millimeters. Some printers, it's as much as 5 or 6 millimeters. That is greatly reduced by having a direct drive. And as I said, it eliminates most of the boden tube. So I picked this up from a company. I'll put a link below. And while I was at it, I picked up another item they have. It's a small lighting kit. Basically, it's just a small strip of LEDs, and it tapes to the underside of the cover for the hot end. And another thing that I'm going to be doing along with this is I'm going to be changing the type of fans I'm using for cooling. There's two fans, one that cools the hot end, and that is going to stay stock. The other fan is more of a duct fan, and that blows air over the tip, and it cools the filament that has just been laid down. So it helps when you're doing angle printing and you want to try to avoid supports. There's less chance of that angle collapsing. It involves a piece that's very complex. Someone did a very nice job of modeling this. There's different versions. This allows for 2 fans, and this is the type of fan. And as you can see, the fan is in here and the exit is here. So all the air volume comes out that one end, and a pair of them plug in to this piece like so. And so there'll be another fan over here, and that provides airflow out either side of this 3D printed piece. So this is going to replace the existing duct fan and provide better cooling. Now, depending on the material you're using, you wouldn't necessarily want extra cooling, but for PLA, it definitely helps. So that's what I print with most. I'm going to go into different filaments and the associated problems with them in a much later video with a lot more detail, because PLA is definitely the best place to start. If you're getting a 3D printer, you know, avoid ABS. The problem with biggest problem with ABS is fumes. So you'd need a very well ventilated area or some type of enclosure that vents to the exterior of your dwelling, PETG also has its problems. It's very difficult to print with. It's much more difficult than PLA. PLA is just a joy to work with. I mean, there's problems with everything. I've definitely had some clogs, nozzle clogs. The first dozen things I printed were fantastic, and the Ender 3 is a great printer. Right out of the box, I was printing things, not having problems, but as you start doing larger, more complex prints, you start running into things like the need for supports. You run into issues like clogs at the hot end, and learning how to fix those. And PETG I have found to be very difficult to work with. There's a lot of stringing, and that's just the nature of working with that medium. So PLA Plus are probably your best bets for beginners to get started, have a good time, learn some things about your printer without a bunch of catastrophes that are going to kind of change your taste for the hobby. Okay, the first step is to, well, open up the package and you know, kind of inventory everything that's here. Everything's well packed. Here's all the hardware we're going to need. Assortment of plastic brackets and spacers. Very nicely milled aluminum bracket that is going to replace the bracket that the existing trolley is on. And that's going to mainly provide mounting points for the extruder motor up here. I am planning to implement this system, but I don't want to do too many changes at one time. I want to make sure that things are going to fit right, and I can see right off the bat that I will not be able to use this enclosure with this set of fans to maintain the cooling fan. So there's obviously another piece that mounts the fan that cools the top of the hot end. This fan would of course go away because it's being replaced by these two fans with much higher volume. So this I'm going to wait on, and I'm just going to set up the kit as is and evaluate it as such. This is kind of off the track, but this is just an example of some items I got a while back. I talked about them in another video. I bought a bunch of metric hardware in bulk boxes. It's not terribly expensive. I mean, it's a bit of a laydown when you're you know, buying everything that I got, because I bought washers and lock nuts and a variety of other items in assorted sizes. I bought two kinds of screws. The regular, they're all hex head or Allen wrench, but these are the cap type, and these are the domed or round button head type, if you wish. And just to show you what's here, it's a variety of sizes and lengths, and just as an example of where this kind of thing comes in very handy is, you know, I needed two different lengths to mount these. I needed one that just was a little bit longer than the distance across the fan to go into these two arms here, and they just thread in through the plastic like self-tapping, and then slightly longer ones to go in here. Now if this little bit of space here is an issue, I'll just toss a washer over here. But point of fact is that I would have had to do at least one run to the hardware store to acquire these, if my hardware store even had them in a small enough size. Might have had to go to a hobby store or a specialty store of some kind to get them. And I probably would have paid anywhere from, you know, $1 to $2 per, depending on whether they're stainless steel or just steel. And metrics always tend to be a little more expensive because they don't carry a lot and sell a lot. Whereas this entire box was $10 or $11 on Amazon. So I probably spent about $70, $80 on about 4 or 5 different boxes of hardware. But that pays off dramatically. This box almost paid for itself in just those 4 bolts. I mean, let's just assume that those 4 bolts were, let's say, $1.50 a piece. Okay, that's $6 right there, plus the time and the gas money to drive to the hardware store and buy them. So it's already pretty much paid for itself just on one little item. So on with the assembly, or in this case, disassembly first. So the first thing to do is remove the shroud, and don't drop and or lose the little lock washer. When I work on this, I usually just hang this fan shroud over the side there so it's not tugging on those. Just leave the rubber cap on here for now. There's some Kapton tape here, Kapton tape, just to provide a little more of a heat buffer to the cooling portion of the hot end. Go ahead and trim these little zip ties, get them out of the way. And if you haven't already, remove your filament, and then you can there we go. And then remove the boden tube. Save these clips, they'll be needed later. Okay, so now I can just set this down on the bed. One nice thing about this kit, let me go ahead and move the camera a bit. It includes detailed directions with pictures. And one of the things they discuss here at the end is that you should disable ooze, and any of the controls that are related to ooze, like coast and wipe, and you limit your retraction, which I discussed earlier, to 1.2 millimeters max, and then attune from there. Because since you're eliminating the length of that boden tube, the amount of retraction necessary to get the same effect is greatly reduced, because there's a certain amount of play in a tube that long when you've got a piece of filament stretched through it, especially since it's on a curve and not a straight line. Now, one of the things I did in a previous fix that I didn't go over, excuse me, is I replaced the mechanism up here, the plastic parts, with aluminum parts. It's a common off-the-shelf item, a mod a lot of people do. It's not really a mod as much as it is just replacing one item with something that is stronger. Just gonna pull this drawer out and keep it aside for now. Parts out of it. This wheel is one of the items that I printed right away to have an item, and I made a change to it. The motor shaft is D-shaped. In other words, there's a flat surface where you can lock in a grub screw, And as you can see, the hole is shaped appropriately. I drilled a hole and threaded in a grub screw, so that locks this little wheel more solidly onto the end of the motor shaft and makes adjusting easier. It's less prone to falling off. This is another item that is not going to be needed anymore. Since I'm removing the boden tube and going to direct drive, the filament is not going to be passing directly adjacent to the jack screw, and thus it's not going to need this little guard here. Before I get too far, I should unplug the motor. And one of the things that they provide in this kit is an extension cord that will extend this wire for the stepper motor out onto the gantry. It's a very complete kit. One thing I haven't seen done as a modification, I've seen people relocate the power supply, which is something I've considered doing down the road. I haven't seen anybody put a secondary jack screw. One way to make this more reliable would be to have a mechanism like this on the opposite side, and have an identical jack screw and stepper motor on the other side, so it's lifting from both sides of the arm as opposed to lifting from one side where it, you know, has a, you know, it's never going to jam, but I mean it's just a weak spot. And if you look at some more complex or higher end printers, they tend to have dual-sided lifting mechanisms. One thing I have noticed as a potential issue, one of the nice things about getting this aluminum kit is they provide a stiffer spring for this arm that presses against the gear here, which feeds your filament. And sometimes if the filament is starting to clog, this motor, the gear will slip. It won't have enough traction even with the pressure against here, and it'll slip. You'll hear the gear notching, sliding against the filament instead of feeding the filament. And that's a good sign that, you know, A, you're starting to get a clog. But its advantage of having a stiffer spring is more pressure against the filament, less likely that happens. This is another item I 3D printed early and also put a grub screw on. Now, if you were doing this on a stock unit and you have plastic up here, check this to make sure that it's not cracked or damaged. That's one of the things they mention in the instructions, that the plastic items are prone to failure at that point there, and cracking, and then that is going to reduce your tension. Eventually it'll completely reduce tension when it fully fails. Uh-oh, that's a problem. I've got a bolt there that might be a little stripped. I hope I can get that out without having to drill it. That would be a pain. Just goes to show, even Allen heads can strip, which is one of the reasons that I both like and dislike this type of Allen bolt, of Allen wrench, where it's got the knob at the end. It does allow you to work at an angle on a bolt as opposed to coming at it straight on. The downside is that it's a reduced amount of surface area, and that can lead to stripping. I'm gonna go ahead and get this last one and then see if I can coax that last one loose. That one's a little stripped too, almost. And see, also that's a problem with low tolerance tools. Okay, this is see, this one's starting to wear. I'm going to go ahead and pause the video. I'm going to take a Dremel. I'm going to trim the end of this so I've got a clean surface, and hopefully I can extract these last two bolts without having to drill them. Okay, problem solved. I trimmed a couple millimeters off the end here, had a nice fresh surface to work with, and was able to get both of those bolts out without any problem. So sorry I didn't show that process. I just got caught up working. In any event, it's time to move onward. So the next step is to remove the carriage. So I'll start with, yeah, might as well just do these two. They're all going to have to come off completely anyway. Should have done this earlier, but got a loosen tension on the belt. So I can slide these off like so, and we'll just leave the belt draped down. Okay, so here is our old plate, and here is our new plate. Okay, they must provide a spacer for those two holes, because these look like the two holes that are going to match up for the hot end. There's a couple extra holes. They may be for you know, other configurations. So the next step is basically reinstall this hardware in the reverse order. Probably the easiest thing to do, aside from backing off the tension, is just slide that in all the way, get as much tension off of the belt as possible. Make sure there's no twists in the belt when you reassemble. Now these two you can snug down nice and firm. They don't need to be crazy tight because you've got a locking bolt that's keeping this from loosening on you. The eccentric bolt is going to provide the tension, so you want them tight, but you don't need to crank down on them or anything. And the spacers are aluminum, so you don't have to worry about collapsing one of them or something like that. There's just no benefit to over tightening. Now the eccentric bolt is adjusted so that the trolley can move smoothly. That's strange. Okay. Just been looking over the directions. There's a few things I'm gonna kind of have to change or deviate from. Got a few different options. If you have one of these metal kits, this does not work with it. This is the spacer, and as you can see, that doesn't work. Now I could easily just trim this to be two separate pieces or cut triangles out of there to make clearance for this, or I can just go ahead and use the original piece and still continue to use the metal arm and the stiffer spring, and that will work also. And I may just go with this route. Do not skip the step of putting the provided spacer, this is the spacer they provide, in here in between this plate, regardless of whether you're using metal or plastic, because this takes the place of this metal plate, and the length of the bolts is specific. You have the assembly bolts here, here that travel through the motor, and if you don't put that in there, you're going to bottom out against these screws and potentially push them back out, which might tear threads. At the very least, it'll start unscrewing them, but at the worst case, it's going to push them out, and you're either going to rip threads at this end or rip threads on the inside here. So avoid doing that. Make sure you use this spacer. So you're going to take the extruder assembly apart, you're going to put this spacer in, you're going to put this on, you're going to put the one screw that is countersunk here, and then you're going to put the screw for the arm. You're going to leave these two screw holes empty because those are going to be the mounting holes for these, and motor's going to mount up here like so. The only thing I'm not thrilled with about this kit is not having visibility of the filament as it comes between the gear and the arm. Let me just go ahead and put this in here, because this assembly points downward like so, and it's mostly, or the bottom, the end you'd want to be able to see is partially covered. May or may not be an issue. Another thing that I find kind of odd, it sounds as if they want us to remove the boden connector from here. And that would be another reason to stay with the standard plastic item, because this piece is a larger thread than this one, so the hole is bigger. So if we are in fact just putting the piece of boden tube in here into this hole, and not using this clamping mechanism, that's going to be, there's less room for the hose to move around in this hole versus, I believe this one is a smaller hole, different thread. Yeah. See, as you can see, one bigger than the other. So a lot more room for the hose to move around in there versus in here. Not that that's a problem. I want to confirm that we aren't using the boden connector there. I believe they said, let me get to that part here. Yeah, so you can actually see an image where the, and it says, note, direction of the stepper motor plug, important to note the direction of the stepper motor plug. Remove factory boden coupler. Now, I don't believe it tells us to reinstall it at some other point, and if you look at their image of the hot end, it has the boden connector in the hot end and just empty tube above. If you look in this image, you can see the boden connector at the hot end coming out of the extruder mechanism. You can see the stepper motor, and if in fact the boden connector was on the stepper motor and you were looking at it this way, you should be able to clearly see the boden connector over here if it was there in fact. They give you a very specific size length of tube to cut, although they're kind of vague at that. It also, some things about this instruction are kind of off order. Like they'll show the fan mount in place in some images where it's not completed, and then they'll show it off in another step and then back on again. A little confusing. So, but I'm just going to kind of take this a little bit at a time and figure out how I'm going to make it work. So I'm going to start at this point by fitting the hot end and figuring out how everything else is going to go based on that. Now that, I got the right screws. I see why that's a problem. Okay, here's something to consider. The hot end has 2 bolts with a pair of lock washers. Now, this normally fits up against a pair of offsets that are threaded, whereas on this one, the plate itself is threaded and you have a spacer to make up for these 2 offsets. Now, why I see that as a potential problem: number one, the offsets and the spacer are not the same size. The spacer is a good bit bigger. That means we're going to have a slight difference of location. So I may put a washer or 2 in here to try to make up for that. I mean, ideally you want the hot end to be in exactly the same position. I don't think it's going to make a big difference, but there is one problem in that this hardware doesn't really work now, because as you can see, there's very little bolt sticking through. The obvious solution would be to remove the washer. If I remove the washer, I've got enough material to be able to bolt in there, but I don't like the idea of not having a lock washer. I mean, there was a reason it was provided. This does get a lot of vibration and moving around. So the next step would be possibly to just use a larger or longer bolt if you have one. I'm going to check my little box of bolts here and see what I've got. Okay, that's the same size. Okay, I've got some that are a couple millimeters longer. That way I can use the lock washer. So I'm going to use a pair of those. Just for your reference, those are M3 by 20s. And it looks like what's in there is an M3 by 18. So if you have access, I would swap those. And there's nothing directly on the other side of the plate. If there's any bolt that protrudes, that is going to be an issue. I'm not going to tighten these down just much past basically snug for right now, because I want to kind of test fit everything. Speaking of, let's just kind of see that. Okay, looks like there's a threaded hole here and here. So this mounts right in place. Now, as you can see, there's a couple of holes here and here that are countersunk for bolts to go through from this side. There's no hardware that we have for the Ender 3 that could possibly require those two holes. So this is obviously a multi-use plate for different kits. I hope you enjoyed this video. Please click like and please subscribe to my channel.